We have our auditing in place. Excellent. Okay. Now let's deal with concurrency control. So, one of the things that okay, I mentioned here in my copy paste file, it's quite often the case you'll find that any entity that is sort of important enough in your overall scheme of things to have an audit trail on it, you probably want concurrency on it as well. If that is the case, don't add this to the iAuditable interface, but in your actual Audible class, you could throw in this row version property right here. And then it's just automatically inherited by every entity that is auditable. I'm not going to do that today though, right? Because I want to audit my patient, but I don't necessarily need to audit the doctor. I've decided in consultation with the client who's paying me to build this application for them, the medical office, that now they don't really make enough changes, to the doctor to worry about auditing, having an audit record of who last updated the doctor's information. So we just want it in the patient, okay? All right, so basically we're going to add one little property here. Now where I put it is totally immaterial, but anything new I usually add, I put near the end, but usually above any foreign keys, right? So here, I'm going to put it after the email. The coverage isn't technically a foreign key, but it kind of, anyway, wouldn't be wrong to put it below coverage. Wouldn't be wrong to put it anywhere for the most part, but try to be organized in your approach, and you're consistent yourself. So what do we have here? I'm going to call it row version. Notice I have a comment. I'm added for concurrency. What data type is it? Well, it's a byte array, an array of byte characters, right? Now here is the trick, okay? The annotation timestamp, that is what actually will tell Entity Framework Core to use this for timestamp or concurrency control, right? And notice I've again added scaffold column false so that if I planned ahead and had this in my entity right away, the system would know not to scaffold and input control for this row version, right? Okay. All right, so that's it. I'm only going to track concurrency for the patient. So now I've added that to it. Guess what? We need yet another migration. Well, I can try just adding one. I should probably be able to get away with it because I'm just adding something new, right? Come down to the NuGet Package Manager. Patient. Timestamp, I'll call it that. Okay. So interesting to notice this. That's one reason I want to go through this. See, it's a byte array column, but what data type is it actually going to use in SQLite? A binary large object. No, it's not a horror movie from the 1930s, a blob, a binary large object. Okay, that's how SQLite stores the row version itself. All right, so that's good. I've got it created there, and I'm quite certain we should have no problem. If I wanted to, I could try updating database. Yeah, okay. Why don't we do that? Just in case there was an issue, we'll see some code underlined in red or yellow if there's a warning. Nope, no fancy colors. So we're good. We were able to update the database. Of course, right now, what am I set for? Okay, I'm currently set to actually delete the database and recreate it anyway. So actually, maybe I'll make that false right now. So my one record I updated, that audit information will still be there. Okay. All right, so we've added our timestamp here. Now, as we said, in order to maintain that binary large object inside of the actual database table in SQLite, we're going to have to create a trigger, actually a couple of triggers, right? So rather than using the migrations itself, because we delete and recreate them, I can come into my initializer. In the prepare the database area, look at this. I've already was kind to you and put, here's a good place, right, to throw some additional code, okay? So that's exactly what we're going to do. We're going to create the triggers, right inside here. So I'll just share this code with you, but we'll have a look at it together, okay? So I'm going to define a string for my SQL command, right? Create trigger, set patient timestamp on update, okay? After update, in other words, so it happens after an update inside the same transaction as the update itself, on my patient's table, right? So I'll update patient, set row version. Now, here is what we're going to do, okay? Unlike other data types, the only real choice we have is create a new random binary large object, okay? An 8-byte binary large object, okay? By creating a new random one, could we possibly ever create the same one twice? Well, highly, highly unlikely. In fact, I'm so confident that I have no worries about this whatsoever, right? So we'll just set the row version to a new random value, okay? Odds of us creating the same random value twice in a row are so infinitesimally small, it's not worth worrying about. And of course, where the row ID, okay, is this new row ID itself, okay? Now, similar for on insert, okay? We're doing the same thing after insert, doing pretty much exactly the same code. And in each case, to execute the raw SQL, we just call context.database and execute it, passing it in. We did something like that earlier in our initializer later on, further down, where we executed raw SQL to delete any doctors that had no patients assigned, right? So it's really the same type of code. We're just creating these triggers. Okay. Now, here's a thought. A moment ago, I shot myself in the foot, right? I came in here to program.cs and I said, no, I'm going to say false, but I definitely want to say true because I need to delete the database. So when it's recreated, we create the triggers, right? Okay. Now I should be good. All right. So let's now put it to use. I can get out of there, save everything, close both of those, come back now to the patient, right? So I'll come to the patient controller. We're going to have to do some work there. And we're going to come to the edit page for patient. Edit view, I should say. Okay. Now for edit, what I need to do is I need to actually store, along with the other information that's hidden away here, right? See how I have the ID? Right along with that, I'm going to store my row version, okay? Right in the same area. So it's inside the form, okay? And we're ready to use it now. It'll be stored inside there so it can get passed back and forth, okay? So let me come to the edit action, the edit post. I'll control MO, shrink everything down, come down to edit post. And we need to add yet another parameter. So I can grab, after we've stored it in the view and it comes back again after an edit, I need to be able to grab the byte array, okay, containing my row version. All right. Now, one other tricky thing about this, because of the change tracker, our entity will have a collection of original values, okay, as well as the current values. So before we do our try update model, I need to add one extra line of code to put the original row version value, okay? Because remember, we went and we got the record from the database, okay? So it contains original values. But what if it was changed by somebody else? Then it wouldn't necessarily be the same. Oh, I got one extra comma there. It wouldn't necessarily be the same as the one that was saved in the view. So we're going to take what was in the view and assign that as the original value, okay, to the patient update because we just got it from the database. Okay. All right. Now we have to catch the new exception. So we did have it here all along. We had a catch for DB update concurrency exception, right? But we didn't have a parameter for it. So I'm going to just put EX there, right? That's for concurrency. And we're going to do a little bit of extra work here, right? I'm going to say, instead of just throw, what I'm going to do is I'm going to add a model error. I'm going to use string.empty, so it'll go right at the top in that summary validation control. Say the record you attempted to edit was modified by another user. Please go back and refresh. Okay, so that's good. Let's actually give that a try now. Here we are. So I'm going to edit the same patient, Brandon Anthony, okay? What I'm going to do is I'm going to right-click, open a new tab, and edit here. So I'm basically editing the same record now in two different tabs. Well, that's good enough, okay? So I'm going to change the middle name here. The middle initial is Z. Pretty simple change, but I'll just save that. Now coming back to this, right? This has the original version of the record when I selected to edit it. So I'm going to make a different change, okay? The phone number ends in 9. We had a typo there when we were first entering the phone number. So I'll click Save, and there you are. Look at that. The record you attempted to edit was modified by another user. Please go back and refresh. All right, it's working. Success. Can we make it any better? Sure we can. Now, it might be a little intimidating at first, the amount of code that we're going to use here, but really it's nothing that complicated. So let's just come in and get it in place and we'll see the effect, right? Just got to look and see where, okay. So this is the entire catch block for update concurrency I'm replacing. Notice it was complaining that I wasn't using my EX variable, okay? But we're definitely using it now. So what are we doing now? So if there's an concurrency exception, as we're trying to do an update, what we're doing, we're coming in here, we go to the entries, okay? And we grab the exception entry, right? This is the one that caused the problem. It's one of the objects returned inside the exception object itself, okay? So we grab it and we get the entity, which is a patient. So we cast it as an actual patient object. So that has the client values, right? This is the values that I'm trying to save. But I can go to the exception entry and get database values, okay? And store that here as database entry. Now, if it's null, okay, then I don't have enough information to do anything else, so I'll just add a model error, unable to save changes. The patient was deleted by another user, because that's the only reason it to be null, is that's maybe what has changed. Somebody deleted it while I was in the middle of my edit, right? Else, okay? What I do now is I actually go to the database entry, convert it to an object, and then cast it as a patient, and that gives me my database values. So now I have two things. I have the client values, the ones I'm trying to save, and my database values, the ones that are in the database. So then it's a simple task of going through and comparing. So each and every one of these is pretty much the same. I compare for the first name, the database value to the client value for the first name. If they aren't the same, I'll add a model error that should display right beside first name. Okay, and the error will be saying current value, okay, and it'll show the first name, right? Same for middle name, last name, OHIP, okay? Now, some of this, okay, we want to give a bit of formatting. So for the date of birth, right? If the date of birth doesn't match across two, then it's the same idea, right? But I'll say string format so that I can actually give it a nice short date string, right? And away we go. Same with the phone number. I can use my phone formatted because after all, it is a fully formed patient object, right? Email, that one's straightforward. Okay, expected yearly visits is good. Okay, coverage, okay, that one's not a problem. All right, now we come down to our foreign keys. They will be a little bit different, right? Our foreign keys, we actually want to actually show the information. Remember, all we currently have are the integers, the IDs of the values. So I check and see if the doctor ID has changed. And if it has, well, I'm going to have to go into the context to the doctors, grab first or default async, okay? I get the doctor identified here by the database values, right? And then I can add my model error saying, hey, beside doctor ID, current value is, I'm going to use that summary property. Another reason why I made sure I always add a property for most of my entities called summary that is a representation of the entity itself, okay? Now, it's even more work, I have to confess, for the nullable foreign key for our medical trial, right? Because it can be null, it's a little bit more complicated. So basically, we have to check if it has a value, then we follow the same approach. If it doesn't, okay, then I'm just giving my own message, current value none, right? In other words, they're not in a medical trial. Finally, I'll add up to in my string.empty, so at the top in the summary, my full explanation of the record you attempt to edit was modified, la-di-da-di-da, and that's it, okay? Note there that if you want to save your version of this record, click the Save button again. Ooh, we'll talk about how we make that magic work in a moment. Otherwise, click the Back to Patient List hyperlink, right? Okay, so to save it over top again, what we're doing here is we grab from the database values the row version, okay, or an empty string, but that's just a backup in case. But we should have it, and we store that in our patient update row version, right? And then next time we click save, it will actually, we're fooling the system saying, no, it hasn't been updated because we've considered all the changes and decided that we're able to save over top, right? So we remove the row version from the model state, and that will then allow us to go ahead and do so. So let's just see that final change. If I run one more time, I'll pick somebody else this time to edit. Okay, so I'm going to pick Ruth here. I'm going to right click, open in a new tab, the edit. So now I'm editing Ruth in 2 different pages. So Ruthie, middle name starts with a Z, 6, phone number ends in 9. Oh, and making lots of changes here. OHIP coverage, out of province. Oh no, I don't want to change that. I don't want to worry about the, okay. Doctor, we'll assign a different doctor. So I'll just save those changes. Now come back into this edit page, and I'll only make one change maybe. I'll just change the medical trial, right? Click save, and there we go. So there's my full explanation. If you still want to save, then click save button again. But you see everything that's changed. It shows me what values are currently in the database. Now that is ideal. That is the perfect display of information to allow the user in a concurrency situation to decide, okay, yep, I can see everything else that this other user has changed. So I'm confident that no, my modifications are correct. Okay, who knows what this person was thinking, but they're all wrong. My version of the record is the right one. I can click save, and now it successfully saves my version of the record. And that's it. So that's the ideal arrangement then, right? So it gives us the best way to handle concurrency. A little bit more work to get all this code in place, but you can see the value to the end user. And that's it. That's our lesson on concurrency.